Relativity teaches us that things aren't always the same when viewed from a different perspective. The key insight here is that it revolves around the observer's viewpoint, even as they remain in the same position. Crucially, nothing in the system itself changes. Only the focus shifts, creating a paradigm shift. In our era of detecting stability, we've been relentlessly searching for it and striving to understand its origins. Since the dawn of scientific inquiry, from the ancient philosophers to the Enlightenment, this pursuit has seen tremendous progress, an acceleration of technology from the steam engine to electricity, from mechanical convergence to fluid dynamics, and now to high-speed computing, internal data processing, AI, and beyond. Stability is the foundation that makes all of this possible, the bedrock enabling innovation and predictability. But what if our current understanding of stability is merely an approximation? Across various sectors, like medicine, economics, climate science, and engineering, stability goes by different names, with varied approaches and successful models tailored to each domain. Yet these are often post hoc explanations, retrospective rationalizations. It's after the fact. You only know someone is sick after the diagnosis. You only realize a market crash after the bubble bursts. You only detect structural failure after the bridge collapses. You only identify ecosystem collapse after biodiversity plummets, and so on, with countless examples from history, like the unforeseen fallout from the 2008 financial crisis or the delayed recognition of pandemics. What if we could detect these instabilities a priori, beforehand? What if we could intervene and stabilize a process before it destabilizes, guiding it toward true convergence? What if we could pinpoint the initial spark that sets off the chain reaction? And here's the revolutionary part. What if this didn't require new technology or added complexity, but simply a relative shift in perspective on what we call stability across all domains? By introducing a meta-stability criterion, a mathematically defined framework, we could uncover universal patterns that were once invisible, revealing the hidden plateau, where true equilibrium lies, before tipping points are reached. This meta-criterion would act as a lens, unifying disparate fields under a single observer-independent metric. Imagine applying it to predict disease onset by monitoring subtle physiological shifts, or forecasting economic downturns through early entropy signals in market data, or even stabilizing AI training by detecting latent divergences in neural pathways. It's not about inventing new tools. It's about reframing the old ones